Okay, good day, class. We are we are group 11, and we are about to present on the input and output in computer organization. And now, before we look at that, we have to look at the input or output subsystem. And with this, it is the unsung hero of the computer organization, acting as the vital bridge between the CPU and the outside world. It manages all input and output operations, ensuring seamless interactions with peripheral devices. So all what you are trying to say is that the input or output subsystem enables efficient communication between the CPU and the peripherals. So the seamless interaction we are talking about is the smooth communication between the CPU and the peripherals. Example is the playing of a video or something. So it's the smoothness of how the video is being played or how it flows. So I'll leave it to my second colleague to continue from there.
So I'll be taking the navigating the word of peripheral device. So when you say peripheral devices are our gateway to interacting with computers. Without them, computers would be isolated machines with no way to receive inputs or deliver outputs. So we have the input peripherals, output peripherals, and the input-output peripherals. When we say the input peripherals, we send data to the computer. Example, the keyboard, the mouse, the microphone, the scanner. We send data to the user or we send data to the computer. So when it comes to the output peripherals, monitors and printers enable the computer to display or present information to the user. So we receive data from the computer. Example, monitor, printer, and speakers. When we come to the input-output peripherals, touchscreens and external drivers facilitate bidirectional data flow, both input and output. So it allows two-way communication. Example, monitor, printer, speakers. So we have the touchscreen, the external hardware, the network card. So my colleague will continue from there.
Okay, so I'll be taking the crucial role of the input and output interface. The interface units are the intermediates that link the CPU bus with the peripherals devices. They are essential for resolving critical differences in signal type, the data registers, speed and data formats between the high-speed CPU and slower peripherals. So imagine your CPU as the brain of the computer, constantly processing information at incredible high speeds. Peripheral devices like keyboards, mouse, printers, and hard drivers, network cards are the sensors and limbs of the computer, allowing it to interact with the outside world. However, these peripherals speak a very different language and operate at much slower speeds than the CPU. The input and output interface acts as translators and mediators. It's a specialized hardware component that sits between the fast, high standardized CPU bus and the diverse, often slower and device-specific peripheral devices. Without the intermediary, direct communication would be impossible due to the fundamental incompatibilities. Yeah, so I'll leave it to my next colleague to continue.
Okay, so I'll be taking the efficient data transfer mechanisms. Understanding how data moves between the CPU and peripheral is key to organizing performance. So we take the first mechanism, which is the programmed I/O or programmed input-output. With this mechanism, the CPU controls each data transfer operation. This often involves the CPU constantly checking the device's status until it is ready to transfer data. This method is a little bit inefficient as the CPU spends valuable time waiting instead of performing other tasks. We take the interrupt initial input output. In this mechanism, the CPU is only interrupted when a device is ready for data transfer. Instead of constantly polling the device, the CPU continues with other tasks until an interrupt signal from the device indicates it needs attention. This method is significant as compared to the programmed input output because for it doesn't wait. Then we take the direct memory access, which is the DMA. Peripherals can transfer data directly to the memory without constant CPU intervention. A DMA controller handles the data transfer, allowing the CPU to perform other operations consistently. This is the most efficient method for efficient data transfer mechanism. So I'll hand it over to my next colleague to continue.
Okay, from this slide, we're going to talk about synchronization and communication. Overcoming challenges addresses a core problem in computer architecture: the vast difference between the CPU and the peripherals devices. So the challenges: the CPU is incredibly fast and operates purely electronically, while peripherals like keyboard, printers, and hard drives are much slower, often electromechanical, and have diverse operating characteristics. This creates a fundamental speed mismatch and a need for coordinated interactions. Without proper handling, we would face data errors, insufficient CPU utilization due to constant waiting, and chaotic system. So how we overcome it? This is the solution for the synchronization and the communication. So we start with the synchronization. This is about ensuring ensuring the operations happen in the correct order at all time. Key mechanisms include interrupts. Peripherals signal the CPU when they need attention, preventing the CPU from idle waiting. Then let's talk about the communication. This is the actual exchange of data and control information with high data volume. We rely on status or control registers. This allows the CPU to read device states and send commands. And also we have the direct memory access, the DMA. This is crucial for large data transfers. So I'll hand it over to the next person to continue with the presentation. Thank you.
Uh, Diverse input and output devices and their interfaces. The world input and output devices is broad, each requiring specific interfaces for communications. Keyboard utilizes II 7-bit code for representing 128 characters, translating keystrokes into digital signals. Data into physical output on paper. Common interfaces. Interfaces like USB, enable stabilized communication protocols for various devices. Now, I'll be passing it to the next presenter. Thank you.
about the advanced input or output, DMA, and channels. So, in high performance system, the CPU is the most valuable resource. If it had a directly managed every data transfer between peripherals like hard drives, network card, and memory, it will be constantly interrupted and bogged down. This creates a severe bottleneck. The DMA solves this by allowing the peripherals to directly read and write to main memory without CPU intervention. Once initiated, the DMA controller handles the entire data transfer independently. So it drastically reduces the CPU's workload. This means the CPU is freed up to focus on complex computations and reading applications, leading to significantly fast data processing and throughput. Also, improve application performance and responsiveness. Another one to better overall. So I'll leave it to the next person to continue. Thank you.
Key takeaways: mastering input and output. Input and output organization is fundamental for efficient CPU peripheral communication. Interfaces are crucial for bridging speed, format, and control differences. Models like interpret driven input and output and DMA optimize data transfer and CPU utilization. A robust input and output subsystem design is essential for diverse peripheral requirements. Thank you.
Okay, so in summary, the input and output subsystem act as crucial link between the CPU